Okay, in this video, I want to write a program to convert an analog value into a digital value using an Arduino. And I'm just showing this to you on Tinkercad. Uh, you could actually do this on a real Arduino, but I'm just showing to you on Tinkercad because it's so much more easier for me to demonstrate how to do it. So what I've done is I'm using A0 as an analog input. Now A0 corresponds to ADC 0 in Atmega 328. And what I'll do is I'll connect this wire here to either the ground or 5 volts or 3.3 volts. And then we have three analog values. And let's see what we get as an input. Okay. We'll use the power supply of the Arduino as the reference. So that's going to be 5 volts. So 5 volts will be our reference. So let's look at the code as to how that works. So here's the code. Let me just make this a little smaller. Now, the main part of the code is what is inside this function called int main void. And that it's just the syntax of writing. So it's main. And what does this code do then? The first thing that it does is it declares a variable called ADC value. Now this variable, we want to store our the value that we get after we do the ADC conversion in this particular variable. Now the an analog value, when it's converted into a digital number, is a 10-bit number because this is a 10-bit ADC. Now we don't have so that's why I have declared this as a 16-bit number. Okay, because 8-bit number is not enough to have that space to store a 10-bit number. So the next biggest is 16. Okay, in the next line, I'm starting a serial uh, connection, basically because I want to write the analog value through a serial connection onto my serial monitor. In the next line, I am initializing my ADC. But instead of putting all the code for initializing my ADC here, I have written a small function here which does my initialization of the ADC. So the way this works is the first line, I am setting ADC marks, AD marks. And what I'm doing in AD marks is I'm only changing one thing in AD marks. I'm putting a 1 at this location, REFS0. Now, what do I mean by that? And what does that do? Let's go to the datasheet and take a look. So here's my datasheet. And if you look at AD marks, REFS0 is in this place. And what I'm doing is I'm putting a 1 in this place. All the rest of the bits remain 0. So when you reset the microcontroller, this register will be reset to 0. And one of the ways you know that is if you look at this initial value. So that's the reset value. So when you start your Arduino, all the values are going to be 0. And I'm just going to make this 1. Now what does that do? So then if you look at REFS, the value that we have is 0, which I have not changed, and 1. So 0, 1 means that I have a voltage reference selection of AVCC. AVCC is the power supply to the Arduino, which is 5 volts. So that is being used as the reference. We've looked at ADLAR, and if you set ADLAR as 0, we just leave it as 0, what happens? Just go down and I'll show you. So the value, the 10-bit ADC value is left adjusted. Okay, so it appears like this here instead of being right adjusted like this. So we have the value like this, and what we can do is we'll just read this value off and just use it directly, a 10-bit value, and print it on the serial port. Okay, let's go back and look at the last 4 bits. What's the value of these 4 bits that we are setting? We're not changing it, so which means that the value is going to remain 0, 0, 0, 0. And that here corresponds to, so the input channel then becomes ADC 0, which is where we connected our signal. Okay, so let's go back to our program and see what else have we done when we are initializing our ADC? We have we are we are setting the ADC SRA register, and what we are doing is basically setting the prescaler here in this case by making ADPS1 and ADPS0 as 1 1, and that sets the prescaler to a value of 8, and we'll just take a look at that. And then what we are doing is we are enabling the ADC by making ADEN bit 1. Okay, so let's go to our datasheet and take a look as to how this works. So ADC SRA, this is what we are adjusting, and the last 3 bits of ADC SRA select the prescaler, right? And we want, I've just arbitrarily chosen a division factor of 8, and if I want 8, then you want the values 0 1 1, and therefore I have set 1 at ADPS1 bit and 1 at ADPS0 bit. Okay, and then I also make ADEN1. Basically it enables the ADC. That means it starts the ADC and lets it work. Another thing that I'm going to use from the ADC SRA register is this bit called the ADSC bit. Now the way this works is here it says in single conversion mode, which is the mode that we are going to use, write this bit to 1 to start each conversion. So whenever we write 1 at ADSC, the conversion is going to start, and then it says ADSC will read as 1 as long as a conversion is in progress. When the conversion is complete, it returns to 0. So you write 1 to ADSC, the conversion starts, and it remains 1 till the ADC is doing the conversion. And once the conversion is over, the ADSC returns to 0, and that tells us that the conversion is over, and therefore we can then read the ADC value. Okay, so let's go back to the program and see how I have done that. So we have initialized our ADC. Now you go into this while loop, and the first thing that I do is I write 1 to the ADSC bit in register ADC SRA. Okay, then we use an internal function called loop until bit is clear. What do you mean by that bit is clear? Remember, in digital language, when we say a bit is clear, we mean that it is equal to 0. And when we say a bit is set, we mean a bit is equal to 1. So here we want to check that this bit is clear, and we want to wait till this bit is clear. Which bit are we talking about? We are talking about the ADSC bit in ADC SRA register. Okay, once this becomes 0, we know that the analog to digital conversion has finished, and so we put the value of the ADC into this variable ADC value, and then we print that value onto the serial port. Okay, fairly straightforward. Now let's take a look as to how this program works. Right now I have 0 volts connected to my ADC input. So what's the value that I'm expecting? So the value that I'm expecting, if you remember the formula that we looked at in an earlier video, was V in divided by 5 volts, which is our reference, times 1024. Okay, so what we get here is, because V in is 0, we should get an output of 0. Let's take a look. So let's start the simulation, and let's switch on the serial monitor, and you can see that you're getting a series of zeros as a value. Let's connect it to 5. What do you expect when we connect this value to 5? Remember again, the formula for the value is 5, which is V in. So V in divided by 5 times 1024. So V in is 5. So 5 divided by 5 is 1 times 1024. So I should get 1024 as the output. Of course, you don't get 1024, you get 1023, one less than the number that we want. So let's start the simulation, and you start getting 1023, which is the maximum value that you can get in this ADC, right? Let's connect it to 3.3. What's the value you should get for 3.3? Maybe one of the things you can do is you can pause the video and calculate the value that you should be getting. You should be getting 3.3 divided by 5 times 1024 minus 1, I think. So you will get value of around 675 if I'm not mistaken. So let's start the simulation, and there you go, 675. So you can see that with different analog values, you're getting digital values corresponding to those analog values.